Alright, hello again, this is Andrew, back for another video on continuing the Offseason Stronghold robot project. It's currently like 12:30 in the morning. Not the most tired, I've been staying up till 3 the past few nights. Not the smartest decision, but I'm not as awake as I was when I started this, so excuse me if I do sound tired. So we started getting the drivetrain together in the last video, and on this one I want to start getting the gearbox made. So first step is going to be figuring out what speeds we want and how to get those ratios and what gears we want to choose. So I want to make it a 2-speed shifter. I know that. I want a high gear around 16 feet per second free speed, a low gear around 7 to 8. So, let's see what we can do. I want to start off, my ideal situation is I make this a 2-stage gearbox. Unfortunately, that's pretty difficult to work with. So, I'll start, make that 12, and then I'm just playing around with the numbers right now. Okay, wow, that's... Oh, duh, I have wheel diameter is 3 inches. Change that. I'll make sure. 2, 2, nice, okay. And I mostly want to use COTS gears, just to prove it can be done. 1323 has, in the past, especially this past year, made our own custom dog gears. And they work great. They're fine. But I want to see, I always like challenge myself to see if I can get it done using less. Now, let me think, how do I want to do this? I want to get it done in 2 stages. Realistically, I probably could. But, unfortunately, trying to get it to all fit in the spacing I want, because I want to make this a inverted flip sim drivetrain. In order to do that, I think I'm going to have to compromise and go to 3 stages just for the sake of time. Because I can easily spend an hour and a half on a video just on JVN's mechanical design calculator. But, actually let me model something really quickly. Cool. Really quickly, I just want to test something out. I've made quite a few inverted sim gearboxes, which is why I'm trying this out right now, because I have an idea of how I want to do it, and I understand most of the limitations behind it. One of the limitations is, you get the shifting, the mechanism that connects the pneumatic shifter with the shifting rod is that sometimes gets in the way, because your cluster gear for your motors is going to be here, and that shifting thing is going to be hanging out, or the shifting, I'll call it the shifting thing, that's not the right word. It's going to be hanging out right around here, and I think it's like an inch or so in diameter. Do 1 1/8 for safety. I want to see how big of a gear this can be. Okay. Realistically, I can reverse engineer that. Push it to around here. What's that? So like 1.26. I'm going to 1.26 times 20. Oh, I'm not connected to the internet. Yeah, of course not. Alright, then I will do 44 plus 2 over 20. Let's start with the 44. Okay, so that can fit. I can fit a 44. Can I fit a 50? Maybe, maybe not. If that were an inch, I could. So is it an inch? Do I have that part saved? Of course not. Do I go to gearboxes and have it? cool. It's here. It's this piece. Yes, this. I'm going to open that real quick. I want to see what is the effective diameter. 885 times 2. Oh, 0.885 is the effective diameter. Shoot, okay, I have a lot more than I originally thought then. Huh. I always use an inch. Nope, 0.85, so I'll have to do 0.9. Cool. So, I could put that to 50. Could I put it to 54? Ooh, maybe? Maybe. I can put it to 54. That's a little close. I don't like it, but if I needed to, I'd probably shave down that bearing housing, that shifting connecting rod. This is nice. This gives me a lot to play with. This gets me in a good zone. That's a little high. That's higher than I want it to be. There's only so much I can do in one stage. But let me play around with it. Let me see what I can do. So let's pretend this were a two-stager. This is my 8-inch wheel. Okay, ooh, You know what? I'm gonna do it. I shouldn't do it. No, I won't. Yes, I will. Okay. What I'm gonna do is, over the 2016 season, 13-23, made our own 54 and 64 tooth dog ears. And as much as I want to stick with Kotz gears, this just makes this packaging solution so easy, and then I can do it in 2 stages and I can be done. So I'm gonna do this. Yes. So this is how I'm going to model the gearbox. This is my 60 tooth gear. Actually, I'll model the... Actually, I need to make this a... Ooh. Actually. So that's going to be 14 plus 64. Hold on just a minute. Why is that point... Oh, that's supposed to be 0.9. And this is going to be 64 plus 2. Can make that any bigger. Make it a 60 tooth. I can't make it a 60 tooth. Ooh, it's really close. Is it worth making it a 60 tooth? Is it worth having to? Ooh, that gives me a little bit more freedom. Verse 54. No, I'm not going to do it. I'll keep it at 54. Okay, so that's that. That works out nicely. And then this is going to be my 54 tooth gear. And I'll have my 24. Nice. And let's go to my gear or my sim. And that's going to exist somewhere out here. And that's going to have the 11 tooth pinion that has the same pitch or pitch diameter as the 12 tooth. So I'm going to calculate its outer diameter and the gear spacing as if it were a 12 tooth gear. Really love that these swappable pinions. These are nice. 12 and 54 divided by 40 plus 0.02. Nice. Ooh, wait. Not enough. Oh, I thought it would be enough. Okay. No. Yes, no. Okay, no. So the problem is, this sim is going to be going into the gearbox, and if it does so, it's going to interfere with the 24-tooth gear. And if that were 60, would it? Yeah, it still would. Yeah, so it's not worth it. Okay. So my solution around this I came up with a while ago. Or I came up with it for the, I came up with it between the 2015 and 2016 seasons. Is to make an idler gear. And it was alright. We ran it this season, and it worked out well. It could have been a lot better. I wouldn't say it hindered us too badly, but I wasn't the happiest with it. And there was something I realized we could do to fix it. So I'm going to play around with that. So if you remember the 4.5-inch line from mounting on the tube, this is where I get this mounting pattern from. Oops, crazy. You can already guess it's going to be the 15/16. And this is already the full 4.5. The outer ones are going to be 1/96, and this surrounding one is for the surrounding circle is for a counter bore, and it's going to be 7/8 of an inch. This one, however, I'm going to make that an 1/8 because I'm going to go through it with a the whole tool. I'm going to tap it 1032. 125. Nice. Okay. And now I'm going to simulate the top of my tubing, because I know my center drop is 3/16, which means that this center is going to be 3/32 below the middle of the tube, which is an inch. So that's going to be 1 plus 3/32. Oh, 3/30. Did not see that. Cool, so that's going to be that distance there, and this is exactly the top of my tube. And I want my sim just resting on the top of the tube. Not exactly there. Just, though, maybe like a 1/16 above. So if it does somehow bow down a little, it's got the entire tube supporting it. And really, I could do like 0.30, but you know, that powder coat and all that, just adds up. Alright, so how do I want to play this? I need it to be about this far away. Okay. Let's say this were 20-tooth gear. So what would this be? So it would be between... Oops, a daisy. So this would actually be closer to like here. Equals, let's say, 20 plus 54, because this is the idler gear there, divided by 40, plus 0.002. Actually, no. I'm not going to add in the 2,000th for the idler, just because. I have a feeling, which is a terrible explanation, but I have a feeling not necessary. 20 divided by 40 plus, nope, not going to add that in. Okay, cool. So that's with the 20-tooth gear. And that would put it about that high. I could get about that close. Oh, another thing I'm going to do is... I don't want it to be tangent, but there. Move this in. I'm going to model the center distance, or not center distance, but the available distance, whoops a daisy, between my, wait, do I not have my sim modeled correctly? Do I not have it sized? That would be embarrassing, because maybe this could work. But, 0.65. My sim, no, it's not, okay. It's actually slightly larger than I was saying, so it wouldn't have worked. But 2.54 is what I put for sim, just because that's an approximation that ends up working pretty well. They're always slightly bigger. So now I got a 16 advantage between the outside of my sim and my 24 tooth gear. Now let's see, this is with 22 idler. If I did an 18, 18's like the smallest I'd go for an idler. Doesn't make much difference. Doesn't know. So I'll go back up to 20 just to make it a little beefier. It's not going to hurt it. And I'll do 3/16 inch hole. And to me that means, or I'll just do like 0.2. And I'm going to know that means tap it quarter 20. There's a few ways I'm thinking about how to do this, but no, I'm pretty confident that'll work. Yeah. Okay, cool. Get that center bearing in there, and it has to be 1 1/8. Does it? Yeah. Does it? Yeah. Okay. Yeah, that has to be. That's fine. I can deal. Okay, and that looks good. I can start mirroring some stuff once I get the mounting hole for this. That's not centered at all. And typical sim mounting pattern is 2-inch hole pattern. And that's going to be the same as this 0.196 right here. And I know I'm not going to change either of those, so I'll make them equal. Typically don't make things with an equal relation if you aren't 100% sure that they are going to be equal. If you end up changing something, it can be a pain. Alright, cool. I'm going to offset this by 0.1. The reason I'm doing that is I'm going to just start making the outline of my gearbox. And what that's going to do for me is if somehow my wheels, if somehow the ground comes up or something comes up to touch my gearbox, it's going to touch the plate first before it touches the gear. So this construction circle is my large gear, my 64. Okay, cool. This, I'm going to go vertical a little, and then I'll move off into an arc, which I will make tangent. And the reason I'm going to go vertical at first is this is something RC taught me, is it's more helpful to do that so that when you when you clamp it in a vise, if you have a vertical, or if you clamp it down at least, you have a 2 parallel sides that are vertical like that. It's easier to clamp it down, essentially. So when we're putting it, we want to make the counter bore. That's going to go right here. And that's a separate operation. You can't really do it all in one on the router. Well, you can do it on the router. We have reasons we don't want to do it. And I know I've been told those reasons before, but they have slipped my mind. Gonna be honest here, I do not remember them. I know there's a reason for them, and I probably should remember what it is. But I do not. So we're going to mirror that over. Alright. Cover the top there, and that's fitting nicely. Okie doke. Actually, so I forget. I'm going to model my sims as 2.6. The reason I'm going to do that is because just so that I get a little bit of clearance when I put my actual sims through for the outer plate. And then I'm going to put right here. Oh, I don't know if I want it in the center or not, but so this is going to be an upper mounting hole, essentially. Yep. Cool. It's working out. And I'll offset this from the center by 0.75. That's nice. Okay. I'll mirror that over. Cool, so these two up here and these two down here are going to hold the gearbox together. Nice. Looks good. Okay, I'll start. Oh, whoops! No, I'm not. What am I doing? Yeah, I'll put this in the sketch. Okay. There's a whole thing, a whole pattern I like to do that I cannot remember, or I always forget it rather. There's a diameter, a very special diameter that I do not remember. I'm going to reference it off the DS plate. Nope, okay. And you see most of this looks really similar. You have the counter bores, you have the sim stuff. I'm not doing the double mounting just because I don't need it. I know I don't need those speeds. It is good to have though, but it's these holes I want, so I don't need to make that construction, but I did by accident. Copied over the radius, discard. Let me see, does it have it? Yeah, so the reason we have that is you have these bolts that'll tap into those holes and it'll hold in a bearing pretty nicely. It's a magic number that I forget who found it. Someone found that number, said, hey, it works, and it's good. So, let's try using it. Or at least I try using it. And then I'll keep that the same as these. Huh. For some reason it doesn't feel right. Feels like that's too big. Yeah, no, that's the right size, because if I have a bearing flange at 1.5 inches, or 1.25, sorry. Yeah, that overlaps nicely. Okay, so I'm not going to do the circle, the triangle of it, sorry. I'm just going to have one up and one down. And I don't think I need to do that on this one. I'm pretty sure I can retain this bearing geometrically. Or can I? No, I cannot. Or no, I cannot the way I'm thinking, but I can retain it without these holes. Put them anyways. Yeah. No, I won't. As you can see, I'm great at making decisions. Alright. Nice. Okay. Bearing plates, mid-plane extrude, 1/4 inch, nice. Now I'm going to add a configuration, back config. The first thing I'm going to do, I'm going to go back and I'm going to copy the appearance. Somehow when you go to a new configuration, you sometimes lose the appearance. Oh, oops, I did not copy. Which, in terms of making a robot, does not matter in the slightest. But I like my CAD to look nice. So, as a result, try and make it, at least, I'll try and make the models look nice. Alright. And I'm going to use these, alright, to mark that. That should be 7/8 just to check. Cool, it is. So, I should probably explain what's going on here. I am taking out a large chunk of the material where the gearboxes are, so that the way this flipped sim gearbox works is the sims will actually take up this space on the inside plate. And now on this one I can, this can use a smaller bearing, this can use a 7/8 bearing. So I will add in that extra material. Up to surface. Don't really need to do that because I know I probably won't be changing this from 1/4 inch thickness. Some teams like to do 3/16. The reason I like to do 1/4 is because you cover the whole bearing that way for the 1 1/8 inch OD bearings. Get them all completely covered. And with that, you don't need to worry about anything protruding into the tube. You don't need to worry about, because I remember 971's 2015 off-season robot, amazing robot, but they just got their router finished, which is amazing, and they made their own router, and they go to they want to use 3/16 inch plate for the gearboxes, which works. They really like optimizing over how to make things absolutely the best. So 3/16 is lighter than 1/4. So they go along using 3/16, and it actually gets really close to the tube, and actually one of the bearings is sticking out into the tube. It's taking up the space the tube takes up. So what they have to do is they have to like nub into the tube, which, I mean, they can do. It is a very valid strategy. One can do it. It works. And they did it, and it worked great for them. It's not something I want to do, though. So I use 1/4 inch, and I just pocket nicely. Intelligent pocketing can get you very far. Alright, going back to drivetrain, I'm going to create a new folder. 1323 16.502. And this is going to be the second subassembly, which is going to be my gearbox. Go in there. 1323 16.5 0201. And that's my gearbox plate. And that's actually both plates, is 0201. The next step we're going to do from this is we're going to take these plates to an assembly, start putting them together, and I have a library of common components I'm going to use. Most of it's, very little of this is a custom gearbox. It's just custom plates, and most of the other stuff are all COTS, except for those 64 and 54 dog ears. And I'm going to do that in the next video because I'm running up on a half an hour. Wow, these videos are easily getting to a half an hour. How much time am I spending on this? Okay, it was fine. Looks like that'll be all for not for tonight, but for this video. Let me try and get a few more videos out. Thanks so much for watching. Hope you learned something, and I will see you at the next video.